Hi all. In this presentation, we are discussing about basic concepts of cogeneration. This is the outline of the presentation. We are discussing about cogeneration, benefits of cogeneration, the thermodynamic process of cogeneration, the Rankine cycle and the Brayton cycle for the cogeneration process. Cogeneration is a process of generating two different forms of energy from a single source. One of the forms of energy generated should be electricity, and the second form of energy generated is in the form of heat. Cogeneration is also called combined heat and power. The word indicates that in this method we generate combinedly both power and heat energy. Cogeneration is an important method in which countries use to reduce the greenhouse emissions. Therefore, there is a control for heat production. However, there is a difficulty in handling the generated energy because we have to utilize the generated electricity and heat energy at the point of generation. In a cogeneration system which generate electricity and thermal energy, sometimes there is a generation of mechanical energy in an integrated system. Around 100 years, cogeneration is utilized in various countries for generating electricity and heat associated with different industries. The industries that generating very high heat content as waste heat can be utilized for generating electricity and thermal energy as a cogeneration process. Cogeneration is not a specific process, specific technology. We can combine this cogeneration system associated with different industries for the generation of electricity and thermal energy. There are many developments and research are carried out for inventing different cogeneration methods. There are a number of benefits for cogeneration. The best thing related to cogeneration is that which enhancing the efficiency of the system. Generally, the waste heat that is dissipated to the atmosphere can cause heating of the atmosphere. While utilizing this heat energy, we can utilize the energy for the generation of electricity, which can utilize it for the working of the entire system. And the processed heat, the second form of energy derived from this cogeneration system, that heat can be utilized for room heating, and also it can be given back to the power system for steam generation process and for the working of gas turbine, etc., which in turn increasing the efficiency in the system wise as well as cost wise. Therefore, the cogeneration system minimizes the cost of the system during its operation, and which also reducing the amount of waste heat energy. Cogeneration system allows an independent way to generate the electricity and thermal power for the development of the system and for the working of the power system. The heat derived from the cogeneration process can be called as a process heat. That heat can be utilized for the working of the entire thermodynamic system. In order to understand the cogeneration process, we have to use the principles of thermodynamics. Basically, the Rankine cycle and the Brayton cycle are considered for the description of cogeneration process. Equation 1 represents the utilization factor of cogeneration system. The utilization factor is termed as the sum of net work output and process heat to the total heat input. From this equation, we can understand that the input heat can be utilized for the work output and for the process heat of the cogeneration system. The Rankine cycle is an idealized thermodynamic cycle used for the description of cogeneration process. It is a three-step process. In the first step, the high pressure liquid enters the boiler from the feed pump, and in the second step, it is heated to the saturation temperature. In the third step, the further addition of energy causes the evaporation of the liquid until it fully converted to saturated steam. This saturated steam is given to the steam engine for the working of the turbine system. In the Brayton cycle, we have used atmospheric air as a compressed fluid for the working of gas turbine system. Usually, the gas turbine, which consists of a compressor where the pressure increases. The compressor output air stream enters into a combustor where the fuel is injected to the air and the combustion takes place. The heated combusted products that enters the gas turbine and which expanded and producing the work. This produced work can be utilized for the generation of power. There are systems which combined both the Rankine cycle and Brayton cycle. A schematic representation of a combined cycle system is shown in this figure, where the first part represents the Rankine cycle system and the second part represents the Brayton cycle system. This combined cycle system can be utilized for the cogeneration process. Therefore, the cogeneration process can be utilized for the generation of both the electrical energy and we can utilize the exhaust heat for as the process heat for the power generation purpose. The basic power plants elements of a cogeneration system are a prime mover, which is used for the production of electricity. There is an electricity generator. There is another component for the waste heat recovery. These are the references used in this presentation. Thank you.